Another review topic we have is using the zero product property to solve equations, and this usually involves factoring. So the idea is we have equations and we need to be able to get the equation set equal to zero so we could use the zero product property. So here are basically your steps. You need to move terms around so that you get the equation equal to zero. And then you're going to factor if possible. If you can't factor, then you're going to have to use the quadratic formula or some other technique. So when you're factoring, first look for common terms, and then typically you'll get left with a trinomial or a binomial, something that you can factor in some other way. Then after you've factored it, you're going to set each of the factors equal to zero. So be careful here, because sometimes you might factor out just a number, and number can't equal zero, so that's not going to be part of your solution. But if you do have an x that gets factored out, you're going to get more than just a typical two solutions from a quadratic. Little indication that you might get would be if the highest power of x you see in there is like a cube or a fourth, that's how many solutions you should be looking for. Then after you go through, you set them equal to zero. You're going to solve each one individually. And again, if you can't factor, try using the quadratic formula. So let's go through some examples. So we have a quadratic, and what makes this different than the factoring problems is we have an equal sign. So in order to solve this, we need to move all the quantities to one side. So I'm going to add an x, and I'm going to subtract 10. This gives me 2x squared plus x minus 6. Now, when I'm looking at this, some of you can factor without using like a rectangle or other terms. But when I go to factor it, I'm going to take this lead term right here. If you need to use the generic rectangle, we take the 2x squared and we plug it into this upper corner. Negative 6 to the lower corner. And then these two quantities multiply to give me negative 12x squared. So I'm looking for two numbers that multiply to give me negative 12, but add to give me positive 1. That's going to determine the other diagonal. So those two numbers that will multiply to give me negative 12, but add to give me positive 1 would be 4 and negative 3. So I got 4x and negative 3x. Now I can factor out 2x out of here. Then I got 2x times x will give me 2x squared. Or I could have thought if I factored out an x going up. Then 2x times 2 will give me 4x. And then x times negative 3 will give me negative 3x. And then just to make sure, negative 3 times 2 is negative 6. That kind of verifies that you did it actually correctly. So that tells me it's factors, 2x minus 3 times x plus 2. I'm going to set each of these quantities, this one and this one, equal to 0, and then solve. So 2x minus 3 equals 0, x plus 2 equals 0. I'm going to add 3, then divide by 2, so I get 3 halves. Here I'll subtract 2, I get x equals negative 2. So that'd be a pretty typical kind of a problem. Okay, let's look at another example. Okay, so we have some extra terms around here. This time we have a cube, so that kind of tells you how many answers I should look for. I should be looking for probably 3 answers. Move everything to one side, keep them in descending order, highest power to lowest power. So I move the 6x squared to the other side, so let's subtract 6x squared. Here, notice they're all even, so I factor out a 2. I have an x in common in all of them, so I factor out an x. Now I've got x squared minus 3x minus 4. Now this was probably easy enough to factor without using the rectangle. I need two numbers to multiply to give me negative 4, but add to negative 3. So I can use x minus 4, x plus 1. Now if you need to use a rectangle, that's fine. You have x squared, negative 4, you have negative 4x squared. These two numbers multiply to give you negative 4, but add to give you negative 3. So negative 4x and x. And you just got to put your pieces together. And there's pretty much only one way that works. Okay, so now we got our factors. Now I'm going to set each of these terms equal to 0. Now, if this was just a 2, since 2 can equal 0, I wouldn't worry about it. But it has an x there, so I do have to worry about it. So I get 2x equals 0, x minus 4 equals 0, x plus 1 equals 0. Solving, I get x equals 0, x equals 4, and x equals negative 1. Okay, one last example. So we have 2x squared minus 7 is equal to 4x. Now, it doesn't matter what side I put the equals 0 on. I really want to keep my highest power positive, though. It makes it much easier to factor or to use quadratic formula. So I get 2x squared minus 4x minus 7. Okay, well, let's see if we can factor it. You put the 2x squared here, negative 7 here. I get negative 14x squared. Okay, these two squares have to multiply to give me negative 14x squared, but add to give me negative 4x. And it doesn't take long to realize I'm not going to find anything. Because I could factor this, I go, well, I get 14 times 1. I could do 2 times 7, but there's no combination that's going to give me a combination of terms to give me negative 4 when I add them together. So that means you have to use quadratic formula. So when you have a quadratic formula will always work. Factoring sometimes works, but quadratic formula is more work. So we have negative b plus or minus square root of b squared minus 4ac all over 2a. You want to make sure you have that memorized. So in this case, we have a is equal to 2, b is equal to negative 4, c is equal to 7. So I'll do negative of negative 4. That's going to be 4 plus or minus the square root of. Now I got to do negative 4 squared. You've got to be careful. It's negative 4 in parentheses squared minus 4. Anytime you plug in, you should actually use parentheses, times 2, and then c was negative 7 times negative 7 all over 2 times, and a term was 2. So notice when I'm plugging in, I'm replacing it. Now you can speed things up, and this is what I usually like to do whenever I do the quadratic formula. I do my negative b plus or minus, and then I do the squaring of the b term in my head. Negative 4 squared is positive 16. Then I plug in the other pieces. This avoids the issue. Now, if you wrote inside the square root, if you wrote the square root of negative 4 squared, that's incorrect. That is not the correct way to write it. This term, negative 4 squared, is equal to negative 16. The quantity negative 4 squared is equal to positive 16, because you've got to do exponents before you do subtraction or multiplication. That's why writing it like this is incorrect. Okay, we need to simplify in here. So if you need to use a calculator for doing this part of it, that's probably okay. You can say it's negative 8 times negative 7 is 56, plus 16 is 72. And of course 2 times 2 is 4. Now, simplifying your square root, some of you like to use factor trees, and that's okay. You could do 72 is 8 times 9, 4 and 2, 3 and 3. We have 2 and 2. We have a pair of 2s, a pair of 3s. So 6 comes out with the 2 left inside. Or, what I like to do, sometimes makes it go a little bit easier, I try to find perfect squares inside this. Well, I know 36 times 2 equals 72. And I know the square root of 36 is 6. And that might be an easier way for some of you. If you like the factor trees, use factor trees. But it's kind of up to you how you want to go about simplifying it. Now, I've got to reduce this. I can reduce numbers with numbers, square roots with square roots. But look at all 3 of these and see something that will go into all of those. 2 goes into all those terms, so I'm going to divide them all by 2. And I get 2 plus or minus 3 root 2 over 2. Okay, now another way of doing this, which some of your teacher may have shown you, you can break it apart. 4 over 4 plus or minus 6 root 2 over 4. And then this gives you 1 plus or minus 6/4 reduces to 3/2 times square root of 2. That's also correct. Be careful, don't cancel the 2's right here. You can't cancel across addition and subtraction.